Hello and welcome. In this video, we are going to explore a full machine learning project. We will deal with some data cleaning, the creation of a machine learning model, deploying an endpoint, and testing it with a sample file. Our mission here will be to predict the sale price of houses in the Ames, Iowa market. You can find a full download of this data in the video notes. Using housing data to predict sale price is a commonly used project for machine learning education and is a great place for us to start. Feel free to follow along and make your own version of this model and see what can be improved. Today, our analysis will be crude, with the focus on learning how to use Coleman more so than creating the best model or performance statistics. Then, we challenge you to use your skills and these tools available in Coleman to beat our performance. The download will have 4 files available to you: a training CSV, an endpoint CSV, a data description file, and a notes file detailing some of the data sourcing. As you begin, take some time to review the data descriptions as you navigate your project, as it will help you get a sense for what is contained in the dataset. Let's import the data into Coleman. We will be using the training data CSV as we need to build and train a model. This file will have the actual sale price of the properties that we can use as our target variable. In the Datasets section of Coleman, navigate to Add Data, select a file from your machine, and give it a name. A preview of the data confirms that we do have a header, and there are no dates to be formatted. And all the way at the end, we have a sale price variable, which will be the target that we try and predict. By inspecting the metadata, we can see that Coleman is automatically detecting variable types for our columns and has found integers and strings for our variables. When you are ready, hit the Save icon to load your data into the platform. It looks like we lost 8 rows due to a data type mismatch, but for now, I'm going to call that acceptable loss and move on. Now you can see our dataset in the Datasets catalog. Now let's create our quest. Navigate to the Quest tab, add a new quest, and give it a name. We will need our model to work with the dataset we just uploaded. Add an import data block and find the dataset. On any project, I would recommend exploring your data in great depth before building models. Understand the variables, their relationships, value types, and if there is any missing data. After doing some data exploration, here are some of the things I noticed that we will be addressing in the data cleaning process. A lot of machine learning development time is spent on the preparation of data, so it's not surprising that the list of items here is large. I discovered these through visual inspection of the data and reading through the data description document. I will talk about each of these items as we address them in the workflow. I will start with the tasks that subset the data. I have 2 such tasks in front of me, one involving sale condition and the other utilities. Sale condition lets me know what conditions the property was sold under, like the family sale of the property or a sale on the open market. I've decided to remove properties that weren't sold under normal market conditions in an attempt to prevent bias. There's also one property that doesn't have sewer and water in this dataset. I will remove this property since that is drastically different than the rest of the dataset, and I can assume my model will only deal with properties that have both sewer and water going forward. I will do this using some quick commands in Python using the scripting block. Our scripting block has 2 input nodes and could handle data from multiple sources. I'll only need the one, so I'll pass my dataset into both nodes and just use the one. You can see my script is not very long, converting the PySpark data frame to a pandas data frame, subsetting the data, and converting it back. I'll rename my scripting block and give it a description. Next, I'll work with some feature construction. I'd like to change month sold from numbers to months, and we'll use a scripting block for this as well, as Python dictionaries do a great job mapping one set of values to another. Let's call this month sold, and with a few lines of code, can map the values 1 through 12 to their appropriate month names. For the air conditioning variable, a binary value will be more useful to the machine learning model, so I'll create a new feature called air conditioning with the construct feature block and give it a simple condition to make the new column. I'll drop the old column in a later step. Next, I will deal with the lot frontage variable. I noticed on import that this was read in as a string due to some of the values having the letters NA. I'll start by editing the metadata and changing that to a numeric value. Then I'll fill these missing values using the handle missing data block and fill them with the mean value for the column. Next, I will drop the columns that I have deemed not valuable. I chose to drop columns that were redundant, such as the feature condition columns that were largely empty, and a few columns that were unbalanced classes. I also dropped the property ID number, the sale type, and some columns that I addressed in the feature engineering tasks. Next, I'll move on to addressing categorical variables. I'll use one-hot encoding to turn each categorical variable into multiple columns with binary flags so that the machine learning model can process the data. This is a two-step process. First, using the edit metadata block, I'll mark my columns as categorical, then I'll use the one-hot encoding block to finish the task on those same columns. You can see the dataset afterwards has many more columns, and they all contain only numbers. We need one last metadata block here, where we tell the model what our target variable is. We'll add the block, select sale price, and change the machine learning type to label. Now let's add a train test split. This allows us to train the model with one section of the data and test it with another. This is good practice when it comes to machine learning. I'll use 80% of the data for the training, since I have a relatively small dataset. We are now ready to add the algorithm. I'm going to use XGBoost here, as it's a robust algorithm that performs well out of the box and should handle this use case well. I'll add both a train model block, as well as our algorithm of choice, and feed the algorithm and the training data into the train model block. Now we select our label column, and our model is just about done. The last thing I'll do is set up the score model and evaluate model blocks. We will pass the test set into the score model block as well as the trained model. You should always add both of these to the end of your training quests so you can evaluate performance. Once we save and run the quest, we will be able to check out the results. We can look in the score model to see our predicted sale price statistics, and we can look into evaluate model to see the model statistics. At a 0.85 R-squared value, this model could probably be improved with some fine-tuning. Our model is now ready, and we can move it towards production. We can use this checkbox to select the appropriate activities for us, and after a save, can send it to a production quest. I will select real-time production so we can access the model through its endpoint using the Ion API gateway. My production quest will look slightly different, but all we need here is to save and run it before deploying the endpoint. Now we can deploy and give it a name and description. Once deployed, it should tell us active. Head over to the Endpoints tab and we can find our newly created Ames housing. Open it up and we can get testing. I can test a single observation using a JSON message by filling in values for each variable. I've pre-made one here, and we can see that it creates a single prediction. I can also pass it a CSV file with multiple observations. Here we have prepared the endpoint test CSV and can wind up creating a prediction for every property in that file. You can see the results are a predicted value for each property. In this model, we identified the target variable as sale price, so these are the model predictions of what the property will sell for in their current state. I hope you enjoyed the walkthrough and challenge you to make your own changes to see if you can improve on the performance. Thank you for watching.